Today we're going over the topic of absolute extrema, absolute max and absolute minimum. Before we do, suppose there are 10 sections of calculus, and then in our section, the highest grade for test 1 was supposed 94. It wasn't, but let's just suppose. And the highest grade for test 1 in the section 2 was 91. And then in another section, whatever it was. If we take the highest grade overall in all 10 sections, and it was 99, 99 is the absolute maximum grade in all sections in test 1 in calc 1. And the lowest grade would be the absolute minimum. It could be in any section. I would have loved for it to be in my section, but like I said, that's not true. I mean, it wasn't 94, but this is just an example. Okay, 94 would be like a relative maximum for our group. That's the highest grade in our class. 91 was the highest grade in another class. 99 was the highest grade in another class. And it happened to be the absolute highest. So that's what absolute max means. How do we find it using functions? Okay, this is how we find it. We're going to do this example. We'll call it 201. We have a function f of x equals 4x cubed minus 12x minus 1. And they want you to find the absolute maximum and the absolute minimum in this interval from minus 3 to 3 halves. This function here tends to infinity when x tends to infinity. So you have to limit the interval in order to figure out what is the absolute maximum and minimum. First thing we do is differentiate. The derivative of 4x cubed is 3 times 4, which is 12, x squared minus 12x. Minus 12. Factor out a 12, 12 times x squared minus 1. Factor out x squared minus 1, that gives you x plus 1 times x minus 1, and set this equal to 0. So x plus 1 equals 0, or x minus 1 equals 0. That means x equals minus 1 or x equals 1. These are special points only. What we need to do next is calculate f of x at these special points and also at the end points of the interval that was given. So we need to find f of minus 1, f of 1, f of minus 3, and f of 3 halves. Okay, I have a table here. I have minus 3 and 3 halves. I also have minus 1 and 1. I've already calculated f of x. You plug in these numbers in this function here. So you plug in negative 3 here, calculate this. And I got minus 73. You plug in negative 1, 1, and 3 halves. Look at these results. Which one is the highest? The highest one is 7. So the absolute maximum is 7, and it occurs at x equals minus 1. So minus 1, 7 is the absolute max. So if this was a function like an application, the maximum value of whatever it is, like a profit or whatever, would be 7. And it occurs at minus 1 in this interval. The lowest number was minus 73, and it occurred at minus 3. So minus 3 minus 73 is the absolute min. Let me say this again. 7 is the absolute max. It occurs at x equals minus 1. Okay. Minus 73 is the absolute min, and it occurs at x equals minus 3. The absolute max and min are not always necessarily the numbers that you get by setting the derivative equal to 0. They could be at the endpoints, they could be one of these numbers, it could be anywhere. So just look for the lowest and the highest results after you substitute in this function. We're going to do another example, and I'll call this 202. I'll write the example so we can save some time. Okay, let's do this example. F of x equals sine pi x over 2 in the interval minus 1 and a half. f prime of x, the derivative of sine is cosine, so it will be cosine pi over 2 x times, use the chain rule, the derivative of pi over 2 times x is pi over 2. And we need to set this equal to 0, so cos pi over 2x equals 0. That means pi over 2x equals pi over 2 plus n pi, pi over 2 or 3 pi over 2 or 5 pi over 2, etc., plus or minus. Okay. So that means pi over 2x equals pi over 2 plus n pi. So every time you add pi, its cosine is going to be equal to 0. Divide both sides by pi over 2 or multiply by 2 over pi, so you will end up with x equals, when you divide by pi over 2, that gives you x. Pi over 2 over pi over 2 is just 1, and then this is, when you divide this by pi over 2, you end up with 2n. 1 plus 2n. So the first solution is x equals 1. The second solution is 1 plus 2, which is 3. And then 5, 7, odd numbers. If you subtract 2, it's minus 1. So plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 7, etc. But we're only going to consider the points in the interval. At x equals minus 1 is in the interval. So we've got the interval is minus 1 to a half. That's given. So what we're going to do is this. Calculate this at x equals each of the endpoints, which is minus 1 and a half, and then each of these solutions. The only one of these solutions that's in the interval is negative 1, and it's also an endpoint. So we have a negative 1 and a half. Okay, x, f of x. F of x equals sine pi over 2 times x. I've calculated these, so for the first one, it'll be, when x equals negative 1, it'll be sine pi over 2 times negative 1, which is sine minus pi over 2, and that's negative 1. And then for a half, you get sine pi over 2 times a half, which is sine pi over 4, and that is root 2 over 2. Okay, negative 1 is the smallest number, root 2 over 2 is the largest number. So negative 1 is the absolute, okay, I'll write it in red. It's the lowest number, so would that be a min or a max? Min. A half root 2 over 2 is the absolute, I'll write it in red again, max. And that's how you find it. There were no points in between, no special points in between. Like the first example we did earlier, we had 4 points to choose from. Here we only had 2 to choose from.